This is Mr. Martin. These are the video notes for Geometry Honors, section 10.5. We're going to be talking about angles and circles today. Now, some of the information we already know, so make sure you don't get confused about what you already know and the new stuff. There's, again, a lot of information in this chapter and especially in this section. So if you're having any kind of trouble at all, make sure you get help from me or make sure you get help from a classmate or go to the point. But you've got to keep up with the work in this chapter, and I think you found that the amount of information is a lot, and it's easy to get behind. So let's get right into the section here. We've got four types of angles that we can associate with circles. The first one we know already, angles with their vertex at the center. We call these central angles. So here's my circle, here's my center. Its vertex is at the center of the circle, so we could call this AOC. So angle AOC is a central angle. And we know that the measure of the central angle is equal to the measure of the arc. So the measure of angle AOC is equal to the measure of arc AC. They're equal to each other. So if we know one, we know the other. This one we know. So moving on to the next one. Angles with their vertex on the circle. Now one of these we already know. Inscribed angles. These are formed by two chords, so its vertex is on the circle. And the second one is going to be new for us. That's a tangent chord angle. So the way we find the measure of this one is that it's half the measure of the intercepted arc. So let's take a look at a couple pictures. Here is our inscribed angle. We'll call it angle ABC. And we know that the measure of angle ABC is going to be equal to half the measure of the intercepted arc. Okay, so, and again, we know this one already, but keep in mind the key to understanding this section is to first locate where the vertex is, and then remember the relationship of where that vertex is with relation to the intercepted arc. So this is for part A, and then for part B, we have a tangent chord angle. So again, here's our circle, and if you don't know what a tangent is yet, it's a segment or a line that just touches the circle in one point. So there's our tangent, and then I can draw a chord in anywhere. I'm going to draw it right in here. We'll call this angle ABC. Again, this is an angle that has its vertex on the circle. So you see this chord divides the circle into two pieces. You want to think about the arc that's associated with this angle as the one that's inside the angle. So that would be arc AB. So for this one, the measure of angle ABC, again, is going to be half the measure of arc AB. Okay, so vertex on the circle, it's half the measure of the intercepted arc. All right, moving on to number 3, angles with their vertex inside the circle but not at their center. Again, if it is at the center, it would just be a central angle. That would bring us back to case 1. So let's take a look at our circle. Here's the center, here's a chord, here's a chord. I've got 4 different angles here. I'm just going to label them and then we'll label these points A, B, C, and D. So here's my angles 1 through 4, and they all have their vertex inside the circle. And we know some of them are vertical angles, and they would be congruent. So it says the measure is 1/2 the sum of the two intercepted arcs. So let's take a look at angle 1. Angle 1, the measure of angle 1 is going to be half the sum of the two intercepted arcs. So we can see it intercepts an arc over here. I'm going to change colors. I'll leave it as black. And then we have another one, because angle 3 is congruent to that, so this would be for angle 3 also. arc over there. So it's going to be half the measure of arc AB plus the measure of arc CD. Okay, so those are the two intercepted arcs. This would also be for angle 3 as well. And then if we wanted to look at the measure of angle 2 or angle 4, it would be half the measure of arc BC plus the measure of arc AD. All right, so half the sum if the vertex is inside. So that's case 3. We really have one possibility for case 3. And then moving on to case 4, angles with their vertex outside the circle. So there's 3 types of these. We could have a secant-secant. We'll talk about what a secant is. We could have a secant-tangent or a tangent-tangent. So again, the key here is identifying where the vertex is. So let's take a look at case A. So here's our circle. We've got a secant-secant. So a secant, it's kind of like a chord except it extends outside the circle. Okay, so basically it's secant is a line that intersects the circle in 2 spots. So I've got A, B, C, D, and E. And we're looking at the measure of angle A over here. So that's the angle with its vertex outside the circle. So the measure of angle A is going to be half. Now you can see half the difference. So the 2 intercepted arcs, and make sure you put the larger one first. So the it's going to be measure of arc CE minus the measure of arc BD. And again, if you're having trouble identifying these intercepted arcs, make sure that you get some extra help. So that would be the first one, secant-secant. And then for part B, we've got our circle here, and I need a secant. And now I'm going to draw a tangent, so I'm going to draw it so it looks like it just hits at one point right over there. So this is A, this is B, this is C, and this is D. So now we're looking at angle C. So the measure of angle C, again, it's going to be half the difference of the intercepted arcs. So we're going to have the measure of arc AD and the measure of arc BD. So notice these 2 arcs have a common point there on the circle. Part C, tangent-tangent angles. So here's our circle. I'm going to draw a tangent over there. I'm going to draw a tangent over there. Here's the point of intersection there. Here's the point of intersection there. We'll call this A, B, C, and I'm going to put one more point over here, D, because I'm going to need to name that major arc over there. So again, angle B has its vertex outside the circle, so we have to figure out what the 2 intercepted arcs are and then subtract them and take half of it. So the measure of angle B is going to be half the difference of, so the first arc is arc ADC, and the second arc is arc AC. So we subtract those 2, divide by 2, and we've got the measure of the angle. So again, if you have any questions about these, make sure you ask. Keep this handy as you're doing the homework so you can refer back to it. Again, our 4 cases, it's either going to be equal to, if it's at the center, it's going to be half the arc if it's on the circle. It's going to be half the sum if it's inside the circle but not at the center. And it's going to be half the difference if it's outside the circle. So let's take a look at a couple examples And then I'm going to leave you to work on example 3 and 4 on your own, and then you can check those when you come to class. So angle F, the first thing we want to do is identify where the vertex is. So we've got a vertex outside, so we know that angle F, the measure of angle F, has to be half the difference of the two intercepted arcs. So I've got arc AC and I've got arc AB. So I need to find AC still, so since I know that arc CB is 120, arc AB is 50, that's 170, so the rest of the arc over here has to be 190, because those three arcs make up the whole circle. So that's 190, so now I've got that this is going to be half of 190 minus AB, which is 50, which gives us 70. All right, so that's number one. Number two, we want to find angle B. Angle B has its vertex on circle, so we know it's going to be half the intercepted arc. So the intercepted arc in this case is arc BC, so we need to find that. So since I know that the other part of the circle is 160, if I add arc BC to it, it's got to equal 360, so I know this arc's got to be 200. So now I know that the measure of angle B is going to be half of arc BC, which is going to be half of 200, or just 100. So go ahead and work out examples 3 and 4. And I'll put the solutions on the video here, so when you restart the video, they'll be there for you. And then again, if you have questions, make sure that you ask me. We'll see you next time. All right, so here are the solutions for example 3. If you need to pause the video and check these or correct these, go ahead and do that now. And then when you start the video back up, I will have the solutions for example 4. So go ahead and pause now. All right, here are the solutions for number 4. Again, if you need to pause the video, go ahead so you can copy these down. And then if you do have any questions on 3 or 4, make sure that you ask me, or if you have any questions in general on the section. I know there's a lot of information, very important. You're going to need to recognize these when we get to more complicated figures like 3 and 4 as well. Okay, that's it.